the recording is. Okay, so again, I'd like to welcome you all to July 8th meeting of the Embedded Special Interest Group inside the Bytecode Alliance. Yeah, so I would like to start with a recap of the meeting 2 weeks ago, which was Europe, Asia. Unfortunately, I was not able to join, and I just saw that there are no meeting notes available. So anyone has been in the meeting and can recap, or
was that Europe Asia? Because I think this one is Europe Asia.
Europe US, I mean, sorry.
Okay.
Yeah. Sorry, multitasking failed, yeah. So I was reading the title of today and was talking about the last meeting 2 weeks ago, Europe US on June 24th. And I'm not able to see the notes. Meeting
I
notes.
did join. This is from Collins Shiv here, but I think Ashish, you had joined, right? The last call 2 weeks back.
Yeah, I joined. Last call I joined, yeah.
So do you have any brief updates about what was discussed that day, Ashish?
Yeah, they were discussing about LTS and adding the support for VASI SDK about GPIO, I2C, and SPI. So the decision was that I think they don't want to right now hurry up and add the support for I2C and other stuff on VASI SDK. But yeah, I think I recollect this much only from that meeting. Because I think Google and Microsoft, they don't have much interest in adding the peripherals to the VAMR right now.
Hi, Ashish. Sorry, I just joined. Can you repeat what you were saying about WASI SDK?
I mean, in the last meeting, they discussed about, adding the peripherals to the VASI or not, like I2C, SPI, then you have UART and all that. So the decision was, it was not finalized, but I think the decision was not to add them in VASI, but there were discussions around adding it directly to VAMR or not. So that's what in the last meeting they discussed. I think there were some people from the Ghent, right? Ghent.
Yeah, I'm from that team.
Yeah.
So our plans with I2C and GPIO and SPI, the ones that we manage, our plans are to add this in VAMR as like unofficial extensions that resemble as much as possible the width standards that we are building. But yeah, this will be an official WASI P1 extensions.
Thanks a lot.
Maybe something that's also interesting that I discussed it with Siemens, but with a specific team of Siemens. But we are currently also working on benchmarks, specifically benchmarking our WASI P2 I2C interface, and then comparing that with our WASI P1 I2C interface. Our hope is that those benchmarks will be able to be used as like an objective point in our discussion of like, okay, what is the real overhead of WASI P2 versus P1? Where are the challenges here? We hope to to complete this by August and have some very good figures by August.
Mhm. And are you planning to publicly release the benchmark numbers in this channel or?
Yeah, we'll release them here, and maybe in the future we'll also create a publication about it, but we'll first release them unofficially here.
Yeah, cool. So- And you are looking for mainly for throughput, or what is your criteria for benchmarking the I2C?
So from our perspective, latency is the most important one. So we're specifically going to look at latency, not throughput. We could do throughput if there are certain partners very interested in that. But I think for these use cases, latency is often the most important.
Yeah. And I mean, one influences the other somehow. So
Yeah.
And you're doing I2C, and
The
what do you?
benchmarks are I2C. Adding the interfaces to WAMR, we think of starting with I2C, but then also doing GPIO and SPI. And we hope that maybe we can reuse some of the Atom code, because I heard that they actually already have some source code that implements this in WAMR.
No. Yeah, we're really looking forward to the numbers and see the how good it would integrate actually.
Yeah,
I'm so sorry
we
to
did
ask
some.
this stupid question. I was having trouble getting into the call before. Is this referring to I2C interfaces implemented on the host and called from the guest module?
Yes.
Thank you.
And I think yeah, thanks for clarifying. And I think I mean, once we have the numbers for I2C, I think it can be pretty much transported to all the other universal synchronous and asynchronous serial interfaces like SPI and UART as well.
I think so from our current figures that we see, the story is a little bit worse for interfaces like GPIO, relatively. Like in absolute numbers, the overhead seems to be more or less the same. But the thing is that some interfaces like GPIO are just so incredibly quick that, like, relatively, we see a 300% increase in using the component model, and so yeah. But in absolute terms, you can just basically the numbers appear to be almost the same between the different.
Yeah. And do you already have an idea where this 300% increase is rooted? I mean, for GPIO, it's a little bit unfair because it's basically an instruction. So the baseline is pretty quick. So
We don't really have an idea. If somebody has an idea of how to dig deeper into this, feel free to give us some pointers. I think we can do maybe some traces, some flame graphs to figure that out. We'll take a look at that.
Oh, sorry.
So we're doing it for both WASM time and WAMR for I2C specifically, in order to get some real comparisons between the two.
Because for WAMR, the overhead depends on how you're doing it. And if you're doing it probably with the imported functions, then they will likely come from the overhead of creating a new frame and copying the inputs and outputs, return values, things like that. And well, compared to setting one register value, which is just write or read, it's quite long. And I assume it's the same for where wasn't time, maybe a bit more complicated, but I have never messed with it.
Overhead from guest to host call, just for the, I'm a lot more
Yeah.
interested in the SPI interface question, only because it seems like that's a much more serious problem, because a lot of the typical use cases, at least ones that I'm involved in, involve displays and other much more high-speed devices, where there's sustained throughput and relatively large amounts of data. So that seems like a much more interesting use case.
Yeah.
Oh,
Yeah.
another interesting use case.
We did it for USB, and those numbers we already released. But for USB, we saw only a 1% decrease in throughput, for example, and less than 1% decrease in latency. But USB has much higher overhead than something low level like SPI. Our current benchmarks show something of an overhead of like, let me get the graphs here. Maybe I can share my screen.
This is a USB CDC.
What do you mean?
The USB control data, basically just serial over USB, versus other USB protocols like a human interface device or mass storage.
So we use mass storage to find throughput, the throughput overhead or the throughput reduction.
Oh, cool. That's a much more real number.
I mean, for I2C and SPI, there are many things, but I think a huge factor would also how you use it. So how many bits per guest to host call you transfer? I think if you do an byte by byte guest to host transfer, then you will have a huge overhead. And if you somehow like have a, I don't know, quarter of a kilobyte buffer to send over SPI, I think the overhead might shrink a little bit, or might shrink enormously.
Okay, so I'll try to.
That was literally going to
share.
be my next question.
Sorry, Ron. Yeah, I didn't
No,
want to
thank you.
take your thunder. Yeah.
Not at all. We have the same problems, I think, that we're trying to solve here.
I mean, it's not a new problem, yeah. So, okay, cool.
So this is latency of reading data from an Arduino using read bulk USB. And here the latency difference between native and WASI, this is WASI P2 in WASM time, is in the order of like 7 microseconds, something like that. Which depending on your use case, from our perspective for USB, this is not really a significant overhead. And then this is also WASM time, also WASI P2, but then for GPIO. And this is with the WASM implementation, we're at a latency of this is something like 1,200. I think this is microseconds.
It's on the axis, it's called nanoseconds. So it would be 1.2 2 microseconds here. Yeah.
And then the native implementation is less than 500, maybe 250 nanoseconds. So like in percentage wise, it's a very large increase but the difference between different controllers and different kernel drivers for the GPIO controllers and stuff like that seems to be larger than the difference of the added latency of doing it with WASM time with WASI preview too. But for these ones, I think we really need to go and take a look at where does this latency come from.
What is the operating system underlying these measurements?
So right now we use something that I want to change. Right now we use the latest version of Ubuntu server. And so I actually want to switch it back to Raspbian because I know they have much better drivers than Ubuntu.
Is it in user mode or kernel mode?
Is what in user mode or kernel mode?
The wasm time process.
Wasm time is just running on top of the operating system, so user mode.
Okay. And yeah, okay. And I guess it doesn't have the preempt kernel, right?
Nope.
Or the preempt patch. Yeah, okay then. Yeah, thanks.
Would that be something interesting to take a look at how preempt changes this?
Yeah, I know that all of these add quite a much latency, especially if you're doing these kind of low-level things.
Yeah. Okay. Okay, that might be the best one because we were also wondering like the difference between native Raspberry Pi 4 and Raspberry Pi 5, like what is the difference here? But maybe with preempt at least we rule out scheduler weirdness and stuff like that.
Yeah.
So we'll do that. Yeah. These are just results from students that we are now going to recreate ourselves and verify if it actually makes sense.
There is the equivalent of an intrinsic in the component model, which is called canonical built-in. And maybe it makes sense to just extend the specification to get really down to inlining these host calls into the ahead of time compiled code.
And can you share a link to that?
Yes, of course. This just came to my mind to just really cut down on the overhead for the. It's basically like inlining your call into the host, and that should give you the minimum latency possible. But of course, at the cost of just I would not want to call it fork, but just introducing another specialized intrinsic or specification change into the component model. But it started with 3 ones for WASI P2, and now with WASI P3, it's roughly 30 of them or 40. So they're really growing in number, and it's actually meant as a type of call which is not composable. So something you directly make towards the runtime environment. And so it's supposed to be quick and also some sort of, it's more like really a low-level system call than anything else.
Okay, that's interesting. And these also don't do any lifting and lowering and stuff like that. Okay.
Well, they're not specified to do lifting and lowering. Of course, the arguments have a specific meaning.
Yeah. So I was wondering, do we, from this embedded group, do we already have an idea of what our latency requirements are? That would also be very useful for us to have an idea of what the actual target is here. It doesn't need to be like a canonical latency figure, but just one partner saying, okay, for this use case, we need we have a budget of at most this amount of additional latency.
So for me, it is hard to come up with a specific number. Oh, nobody's taking notes today, by the way, meeting notes. So and this is something to write down. So if somebody volunteers, wink, wink. And yeah. So I don't have a specific number in mind, to be fair. I think what we would need is some kind of a deterministic behavior of the latency that I somehow can then factor it in. So if it's like a garbage collection thingy that latency is somewhere between this and that, and you it's a surprise when things will happen, it's might not be feasible for us. But if it's a narrow latency or jitter jitter limited window where I can say, okay, I do an action on the hardware and it happens later, but I know when it happens. I can predict when it will happen. This would be beneficial. And on the other side, latency as short as possible. But I think this is self-explanatory and doesn't need to be mentioned. But if it's predictable, if it's deterministic, this is something where we can start from.
I think latency also depends strongly on the frequency of the CPU or the buses or whatever drives it.
Yeah.
But maybe to get a rough number, like microseconds and below for fast communication. So if we consider network communication, then you want to have, I don't know, kilohertz to gigahertz to megahertz data transfer, and then you come to microseconds or nanoseconds.
Mm.
And then of course it depends on buffers and how much data you want to bring out and all these kind of stuff. So numbers are a bit hard, but maybe that's the direction.
Okay, those are useful. Yep. Maybe I should also add the numbers that we are showing are representative for Raspberry Pi type devices.
Yeah.
I expect them to be much more on actual microcontrollers. Our benchmarks also show them like the worse the CPU gets, the higher percentage-wise overhead we get from anything WebAssembly related.
Mm-hmm, mm-hmm. Yeah.
I think it's really cool that you're investigating this, but I have not tried to use any of these patterns, rather, at least not microcontrollers, essentially putting the vast majority of the processing into host code and just calling it from guests, specifically because of this exact problem. So it's really cool that you're going deep with some real quantitative assessment. That way, I wasn't basing my work on anything specific except an intuition that probably it wasn't going to work well, but I had no quantitative assessment saying,
Yeah.
here's what you can get and here's what you can't. So this is quite interesting work. Thanks for doing it.
I have to second on this, Ron. Thanks for investigating. And I think especially once we or you figured out what the root cause of the latency is, I think this would be also a very valuable input for future design of the VASI to say that we have certain limitations because this or that action takes a lot of time, and then we can try to basically factor this into the design of the APIs in future that like the latency heavy stuff is not called extensively, whatever it is. So I hunch, just an educated guess, it might be, as you said, the guest to host when we invoke a function and then copy stuff around, and so this might be the root cause, and then this could be something to be put somehow in the design of the interface to take care that the interface is done in a way that these kind of interactions are limited somehow, or at least we can basically move big buffers from from guest to host, and then just put them out. Okay, this was super interesting and helpful. Alan, do you have is any of this already publicly available? Does it make sense to put some links in the notes today, or?
Yeah, so we have some of them already publicly available. I'll share these.
This would be really nice, yeah.
I'll put them in the chat.
Okay. Any other topics anyone wants to share today, or?
Yeah, I just wanted to ask if we can get a little more details about the LTS discussion that happened 2 weeks ago. Unfortunately, I couldn't join. So I wonder what was discussed and what are the next steps.
Yeah, me neither, and I'm missing there are no unfortunately no notes.
Do you know if someone from Siemens attended? Maybe I can just send them an email. Maybe Chris.
I think Michiel, who's in the call, was present, so he might be able to give us an update.
Okay.
I was not present in the last SIG Embedded call, but we had some sort of LTS kickoff meeting 2 weeks ago. Let me check if I can find my notes for that. But it was mainly what we are going to do with I2C implementations in WAMR. So I'm actually not sure what was discussed last week.
So did you say that you had a kickoff meeting dedicated for the LTS?
It was a smaller meeting with people from Collins,
Right.
some people from Siemens, if I'm not mistaken, and Stephen from Atom. Mainly because we are going to do some implementation work in WAMR for I2C. Was just to discuss what were the next steps.
Okay, understood. I think it's probably best if I just send an email to Steven and Chris and see what's the latest on that. Yeah, thanks.
Thanks.
Maybe it would have been good to include Merlin and some people who are working on directly related stuff into that meeting. I don't know. Could be wrong. Maybe you were there, but sounds like it's directly relevant.
I was invited, but I was traveling at that time, so I couldn't join. But I will definitely try to be there for the next meeting.
Well, I wasn't trying to sign you up for something you didn't sign up for. I was just making sure you were included because I really want to know what you have to say on this. This is super interesting stuff. Was there any maintainers of WAMR involved in that meeting by any chance? Oh, nobody knows. Never mind. When we find out, I'm curious.
Yeah.
I also have some updates I would like to share. So
Yeah, please.
first is Alex Rechten asked for a second maintainer on the Rust VASI P1 target. Because traditionally it was just a single one, and now they're asking for 2 maintainers of tier 2 targets, if I'm not mistaken. And so if anyone feels called by this, he will be glad for you to reach out to him.
I think we already have a few maintainers of the P1 target in Rust. There's myself, there is Andrew Brown, I think. There's one other person in my company. So yeah, I think there is a few already. So was it called out that there's not enough, or?
I just saw the message on the Bytecode Alliance Zulip chat.
Okay.
So
Could you
yeah.
Okay, yeah. Could you send
If
a
you
link to that message so I can
whoa,
just...
I will take a look.
Okay, thank you.
Just to find it. And the other one is that now my code generator for VASI P3 compiling to native is working. I can exchange streams of strings between C++ and Rust. And so that's it's just nice progress. And this is the one I do have a link prepared from, but I will just also share the look up the Zulip chat. And of course, the next step would be to just find a way of using shared memory between components to go for publisher subscriber with zero copy. And this is the next step I'm working on. And C++ was just merged into with Bindgen. So decent C++ 17 to 20 support for the component model there.
Awesome. Cool.
Okay, got the message. So this was sent yesterday, so I guess it's still up to date. So if there's more maintainer there, they don't seem to be listed.
Okay. Yeah, I'll reply to that thread. Thank you.
Thank you as well.
So if I'm reading
Sorry,
that correctly, it's basically saying they're going to demote WASM targets unless another maintainer steps up.
Not yet. And I think this is actually, given there's many people interested in the maintaining this one, I think that is not a likely event to happen. So basically, they're trying to actually make the already existing targets catch up with their new policy.
Thanks.
Oh, we have a volunteer already. Thanks, Marcin, for stepping up.
As a very active user of the WASM 32 unknown unknown, I hope a maintainer steps up, but I'm not. My chops are not ready, nor my time available to actually do it. Mostly more the latter than anything else that prevents the former.
Yeah. Yeah, so many things to do, so little time.
And you're targeting embedded devices with unknown, or is it the
Yes.
browser? Okay, yeah, that makes perfect sense. I think traditionally it was confused with targeting the browser, and then it just got very murky.
Mhm.
I first mostly became aware of it from people doing, zero trust or other type things, which I'm not too directly involved with, but it piqued my interest and then discovered it could be quite useful for embedded scenarios.
Mhm.
I just found that porting existing Rust crate forests to WebAssembly is much more easy if you just have a target which supports random numbers, which is not unknown, but P1.
Mhm.
So this really made a huge difference to me in getting rid of a lot of special case code.
Mhm.
So I feel P1 or P2 is actually more well suited towards embedded devices than unknown, which really has no real support.
Mhm.
It has whatever support you imbue into it yourself, which
That's true.
is, with all its pluses and minuses included.
Yeah, it's a very manual target. Yes, I agree.
I think I recall your talk from the Vasmayo run, where you mentioned that you're using unknown. Did you do this OpenCV thingy and has a target unknown for that, or did I
Yeah,
mix things up now?
well, but I don't consider that an embedded scenario. It's more,
Mm.
I mean, embedded,
Yeah.
I suppose, but
Mhm.
much more horsepower than we typically talk about in this group.
Mhm. Mhm.
But yes, that's another scenario where, you're on your own, but maybe you don't need to bring, you might need other interfaces that are not inherently part of any other standard anyhow. That said, I've been doing a lot more P1 just because of the reasons Christoph was enumerating. So
Mhm.
who knows how long the unknown will figure so much into the code bases I'm working on.
Mhm. Okay. Do you think it makes sense to look over the LTS document the remaining 15-ish minutes, or is there any other topic you would like to go into? Anybody? Yes, no, or
I say yes.
okay. Okay, then let me quickly share the screen a second. So you should see my screen, I hope. Do you? Awesome.
Yes.
Yes.
Yeah. So I am as we are missing the notes from the last ESIG, I'm down in the version history of this document, and I don't know if it's good to see. I'm a little bit confused with the color scheme choice of Google Docs, but the light gray are the latest changes done 2 weeks ago. Well, there's something about the LTS. I know that we discussed it the last time in this setting, and we came up with similar, little bit higher numbers than 3 to 5 years. I recall talking to Chris that they were talking about development environments and especially how to develop on Windows, which seems to be still a thing people would like to do. Yeah, totally sharing the link. 1 second, I have the link here. So let me quickly jump back to the version history here. And I know that we discussed already offline that it would make sense to concentrate as kind of a tier 1 approach, concentrate on things which are providing a more or less predefined and stable middleware abstraction, like Zephyr operating system. So if you would go too deep or too bare metal, then having a portable solution would be pretty hard. I recall this, and so I think the way right now would be something on top of Zephyr. Yeah. So then we have the change here about how to prioritize actually. So stability. I think it's clear. We still need a way to resolve conflicts or triage different opinions or different ideas on how to solve certain things. I think there's no process defined yet, but maybe this is something done in the separate LTS group. And something which I really what is really important for me is the let's say long-term goal, how to basically have a way back to a joint version 1.0 or something like this. Which and I support the idea here that rather looking at VASI as kind of a spectrum, and that not everybody who implements VASI needs to have low-level interfaces, which do not make sense in a let's say general operating system or even browser context to have an implementation for I2C or SPI or something like this. So basically having making things optional or additional, I think would make sense to converge in the future. Yeah, and then they started an headline for non-functional requirements. Yeah. Is there anything you would like to add spontaneously, or you would like to dive into for discussion?
So for development environment support, I think one of the questions I would like to see answered is WSL okay? We have a lot of experience with WSL. We see that a lot of enterprise environments actually allow using WSL, and that would basically mean that everything that works on Linux already works.
Did I frame it in your idea here?
Yes.
I wonder how many potential contributors actually use Windows as a development platform, because I don't want to exclude anybody, but at the same time, solving a problem that might not even exist might be a waste of time. So maybe we should just kind of test the water and see if anyone's actually interested in having that Windows development environment.
Yes, so we should test the water, and I have a personal opinion, so that Windows is a good operating system to download Linux and then start Linux on your machine. No, I'm not a big fan of Windows, but if we look into corporations, and for this is now more my professional take on this, and I would say the corporate IT infrastructure, also for developers in most of the businesses, I think I can only talk for Central Europe, and I don't have numbers, just personal experience, are still Windows and seem to be Windows for quite some time.
Okay.
And so from a corporate point of view, I think Windows support, I mean, limiting it to WSL, I think is something what is the at Siemens, for example, is the praxis or the status quo, I would say right now. But I would say the majority of PCs are running Windows here. I don't know, Christoph, maybe in the automotive sector, if you have a different experience there.
I've seen WSL everywhere.
Yeah.
Or even people booting Linux natively.
Yeah. So, but the
I advocate for people who may or may not be on this call, but I run in, quite a few Tiny Go users in Japan are running Windows, and quite a few users, some other packages I maintain in China are running Windows. So, although I don't run it myself, except for testing purposes, generally, I'm not sure we can. I'm just advocating for, somebody who's maybe is or is not on this call, but we certainly don't want to just. I mean, I myself run Linux on the desktop for quite some number of years, so I'm just advocating for someone else here.
Yeah.
Yeah. Thanks. Please.
Yeah, I'm not saying that we shouldn't support Windows. I'm saying that maybe this is something that we can add support for once we actually have users who are willing to contribute. Otherwise, we might spend a significant effort making sure that we can develop WASI SDK on Windows, and then find that no contributors actually are interested in that, so we end up maintaining it for no reason. So yeah, I'm not against it. I'm just saying that
Maintaining it at great difficulty since we have no easy way to test it ourselves. Yeah, no, I think you have a very valid point here. If there's nobody who says, yes, I want this and I'm willing to help, who are we? That's very valid points.
Yeah. And I think I really like the input from Merlin to I think if we limit the scope to WSL, which is basically Linuxy somehow, this could be a great improvement or make things a lot easier for us. Yeah. So, but yeah. So asking or getting an idea about who needs what. Yeah. So. There's a comment from you, Martin. Should we also have a section for the extension?
Yeah, this is something we discussed in the past, that a current P1 is somehow limited. It doesn't support memory 64, it doesn't support exceptions, and a couple other things. So I think we will have some extensions, but I wonder if this is something that we should just agree upfront that this is a set of extensions that we're going to have as part of the LTS, or should we have a process that allows us to add more extensions in the future? But again, that's something that maybe we need some input from the community as well.
Awesome. Okay, and thus another hour flew by. So thanks for your input. We are pretty at the end, so I don't think it makes sense to open another bigger topic. Is there something you want to add to this document or something you want to share before we close the meeting? Three to one. Doesn't seem to be the case. I would oh no, I would thank you all for your contributions and for the very vivid discussion. Really enjoyed it. And see you all around. Latest in 2 weeks when we have no, it's Asia, US in 2 weeks, so it's 4 then. Then latest in 4 weeks. See you guys.
Yeah.
Thanks very
Open the
much, everyone.
recording.
Much appreciated.
Care.
Welcome.
Have a nice time.
See ya.